Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Sayyid Muhammad Najm. Now I'm going to explain this topic, micrometers through gauge. After this video, you can easily understand what is micrometers through gauge and how to use this micrometers through gauge to measure the small things like diameter of small spheres or the thickness of small objects or thin objects. You can easily find them. You can easily handle it. Now I'm going to start this topic. This is micrometer screw gauge. As you can see here, the micrometer screw gauge having a screw so that it can rotate easily. And on the rotation portion, there is a scale marked on it, which is called circular scale. And through ratchet, we are rotating it to clip or to handle this thing. We place this object in between the two studs. The one is called the anvil, the second one is the spindle. A spindle is because of rotation. When you move this thimble, it rotates as well as the part of this thimble is actually spindle, which rotates along with this thimble. So it moves and keep this object which is to be measured through micrometer screw gauge. Micrometer screw gauge, how to draw the micrometer screw gauge, because this is very important for class 9th grade and 10th grade and 11th grade as well for 12th grade. So you can easily draw with the help of this simple way of drawing. First of all, you have to draw 3 cylinders of different sizes. These two are of same size, but this one is a bit lengthy, right? And in between these two cylinders, you will draw a piece of cylinder as well. And to measure the object of the sphere through these two studs, we place a sphere here in between them, and the last portion of this micrometer gauge is ratchet, through which it will be locked. The object placed in between the studs will be locked by when the spindle in contact with this object. Ratchet stops it or the clips it. Now, after this frame through which we can handle, or we can support, we can carry this whole micrometer screw gauge. This is circular scale, which is marked on this thimble. The number of circular divisions are marked on this thimble, rotates, and the total number of divisions marked on it is 40, 45, 46, 47, 48, 49, then again 50, right? And there is a main scale marked on this portion. This is main scale, and in main scale, the number of divisions are 0, 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter, 5 millimeter. And in between these two, 0 and 1 millimeter, there is 0.5 millimeter, which is half of this 1 millimeter. So 1 millimeter, if we divide it by 10, so we convert this 1 millimeter into centimeter, it becomes 0.1 centimeter after dividing it by 10, because 1 centimeter is equals to 10 millimeter. So this is 0.1 centimeter, 0.05 centimeter, 0.1 centimeter, so 0.15 centimeter, 0.2, 0.25 centimeter, 0.3, 0.35 centimeter, right? This is the way of reading this main scale. This one is the reference line, and reference line is used to note the circular scale division on circular scale, right? This is anvil, which is fixed stud while spindle is rotating along with the thimble. So it is called spindle, and the last one is ratchet. So this is the way of drawing micrometer screw gauge. Now start the finding the least count of this instrument, because least count is the least measurement taken by an instrument. So when you're going to find the least count of this micrometer screw gauge, you have a formula because there are two scale in this micrometer screw gauge. One is main scale and the other is circular scale. Since a circular scale is fixed along with the screw, so every screw has a pitch. Pitch means the distance between the two consecutive threads of the screw. So it will be fine quite easily if you keep out of this sphere and move this thimble, rotates the thimble forward so that the spindle touches the anvil. It means that there is nothing in between them. So this circular scale 0 will coincide with reference line, and you can see the only 0 on main scale. After closing this spindle and anvil or 0 on main scale, when you rotate anti-clockwise in one rotation of the circular scale, you will see 0.5 millimeter. This 0.5 millimeter is actually the pitch of the screw when you rotate the circular scale one rotation, and the circular scale move back with 0.5 millimeter. And in one rotation, there are 50 divisions rotates in one rotation. So the number of circular divisions are 50. After dividing it, we get 0.01 millimeter. And as I told you back, that to convert millimeter into centimeter, we divide it by 10 centimeters. So 1 centimeter is equals to 10 millimeter. So 0.01 when divided by 10 got 0.001 centimeter, which is the least count of the instrument. And it shows that the degree of accuracy of this micrometer screw gauge, that it can measure the 1,000th part of the centimeter. If we remove this decimal, we get 1, and after decimal you have 1, 2, 3 digits, so it gives 3 zeros with 1, so 1,000th part of 1 centimeter, which is called the degree of accuracy of micrometer screw gauge. Now we are going to find the observation of any object, as we have this object in between the anvil and the spindle, and we are going to measure its diameter, right? For diameter, if we keep this sphere in between the spindle and anvil, we will have this value. As in this instrument, we can observe these values in the way that this is the main scale reading. As you can see here, this is 0, 0.1 centimeter, 0.15, 0.2, 0.25, 0.3, 0.35, 0.4, 0.45, 0.5, and 0.55. So this is main scale reading in centimeter. While the circular scale reading can be found by coinciding it with the reference line. Any circular division which exactly coincide with the reference line is called circular scale reading. So this one is the division of circular scale which coincides with the reference line, and its number is 45, 46, and 47. So 47 is the circular scale division on the circular scale. These are the two observations taken from this instrument. Now we are going to calculate the diameter of this sphere with the help that this division should be converted into centimeter by multiplying it with the least count of the instrument, which we have already found, 0.001 centimeter. 0.047 centimeter is the final least, that is frictional part, which is a bit gap between 0.05 centimeter and the circular scale, which is 0.047 centimeter. Now we add this fractional part with the main scale reading. That is the accuracy of this micrometer screw gauge. That is why we are using micrometer screw gauge. Normal scale can measure only 0.5 centimeter, but micrometer screw gauge can find 0.597 centimeter, which is much more accurate than a normal scale measurement, right? As you know that there are two scale used in this micrometer screw gauge. One is main scale and the second one is circular scale, and both have on zero mark on these two scales. So when we put this sphere out in between the anvil and spindle and move forward the thimble towards zero of the main scale, the spindle will also move and it can become contact with the anvil. When it touches the anvil, the spindle touches the anvil, the circular scale zero after rotation should coincide with the reference line, and the main scale reading shows only zero division. It should be. If it is not, then there will be a zero error. First of all, what is zero error? Zero error when the circular scale zero and the reference line does not coincide each other. Then we call it zero error. Right now, there is no zero error here. As you can see, the reference line have main scale zero, which exactly coincide with the zero of the circular scale. It means that in this instrument, there is no zero error because the reference line coincides exactly with the zero of the circular scale, right? So there is no zero error in this instrument. If these two lines, that is main scale reference line and circular scale division and reference line does not coincide each other. Maybe it is below the reference line, circular scale zero, or become crossing. After crossing the reference line, it goes up. If circular scale reading is division zero, circular scale zero does not coincide with the reference line, then we call it zero error. As you can see here, after locking the spindle with the anvil, the circular scale zero does not coincide with the reference line. And you can see here the circular scale zero is below the reference line, or the reference line is above the circular scale zero, then we call it positive zero error. This is one type of error, while the second one is negative zero error. And how it happens, we are going to identify the detection of the zero error in the instrument. As you can see here, the reference line is below the zero of circular scale. As we have discussed that when spindle in contact with the anvil means there is nothing in between these two studs. So zero of circular scale should coincide with the reference line, but right now the reference line is below the circular scale zero. It means that it has negative zero error. It is called negative zero error. In case of positive zero error or in case of negative zero error, it is our responsibility to calculate the positive zero error or the negative zero error. The positive zero error, when we calculate it, it means that your instrument is given more observation than the actual one. If your instrument has a negative zero error, it means that your instrument measuring less value. Now we are going to find the positive or negative zero error with the help of calculation from with the help of a table to find or to calculate the zero error. So this is zero error calculation now. There's no zero error if zero of circular scale reference line coinciding each other. And in this case, there is a zero error in the instrument, and how to find the positive zero error, how to calculate the positive zero error, we have to draw a grid. First one is same as the observed value, that is main scale reading, which is 0.0, because nothing is seen in main scale. It means the main scale reading is 0, while one division 0, then after 0, one division coincide with the reference line. So this is called, what is called 1, the error. This is called the error. 1 is the error. Now we have to convert this error into centimeter by multiplying it with 0.001 centimeter, which is the least count of this instrument. So the error becomes finally in centimeter is the fractional part is 0.001 centimeter. And to find the zero error, finally, we have to add the main scale reading and the fractional part. So the positive zero error becomes 0.001 centimeter. It means that your instrument is given 0.001 centimeter extra value, right? So this is the way, this is the advantage of finding or the calculating the positive zero error. For negative zero error, as we have seen before, that the vernier scale 0 and the reference line does not coinciding each other, and the reference line is below the circular scale division. Again, the grid showing the calculation of the negative zero error, as there is nothing on main scale, means the main scale reading is 0, while you can see here, zero is not coinciding with the reference line. So we calculate the division exactly coincide with the reference line, which is 45, 46, 47, 48. The 48th division exactly coincide with the reference line. But you can see here, 0 and reference line having only 2 divisions differ from each other. So that is the 2 division error, but the division is 48. That is why we are subtracting this 48 division by total number of circular division, which is 50. So the calculation is clear, the 2 division difference in between the 0 and the reference line. This is the error. Now we are going to multiply first of all this error with the least count to convert it into centimeter, and by adding with main scale, the negative zero error is 0.002 centimeter. This value, negative zero error, shows that your instrument is measuring 0.002 centimeter lesser than the actual value. Now, the final way of finding the correct value, the instrument MicrometerScrewGauge has zero error. And zero error not only can easily be detected, it can be calculated, and also it can be removed from the actual value to get the correct value. Now, this is the time to find the correction of the value. The observation, correction of the observation. Now, the correction of observation is the final, what we have observed, that is 0.597 centimeter is the diameter of that small sphere, right? If we have positive zero error, as I told you, that positive zero error means that there is an excess value measured by your instrument. That is why you have to subtract the zero error from the total rating. Our total rating is 0.97 centimeter, right? and the zero error was 0.001 centimeter, which is the positive zero error. And after subtracting this positive zero error with the total reading, the correct observation is now 0.596 centimeter. This is the value that we can use anywhere, that this is the correct value of diameter of the sphere. On the other hand, if your instrument has the negative zero error, then what should we do? Negative zero error means an less value given by the instrument because it has negative zero error. That is why here you can see the calculation of correction in the total reading, that total reading minus of negative zero error. We subtract the negative zero error. As the negative sign is outside as well as inside, so after the multiplication of negative with the negative, it becomes positive. That is why I told you that this is the excess, this is the less value that should be added with the total reading. As we have discussed before, that this is the negative zero error. The 48 division coincide with the reference line after subtracting and multiplying with the least count. The zero error, the negative zero error is 0.002 centimeter. So according to the calculation formula, the correction formula, that we have to add the negative zero error, which is the less value measured by the instrument, with the total reading in the actual observation. So that is the final value, that is 0.599 centimeter, is the accurate diameter of the sphere. So this is the way to find the measurement to use the MicrometerScrewGauge and to keep the observation accurate. If you have a negative zero error, then you can easily find the corrected reading. If you have positive zero error in your instrument, then you can easily find the corrected value, and you can easily find the measurement of the object through the MicrometerScrewGauge. I hope you all understand easily about how to use MicrometerScrewGauge and how to remove its error. Thank you for watching this video. Please subscribe and like this video. Okay. Thank you from my side, Sayyid Muhammad Hassan. Assalamu alaikum.